who wants to start with the idea of like having one Acme?
I'm happy to take it because I think I initially proposed it. Maybe I don't remember fully, but I know when we kicked off the book, we said in order for us to not just create theoretical scenarios, we wanted to create a company that we can all relate to, and that everything we do, we can always say, how would this particular company solve this problem? And I think it's a little bit aligned with the Phoenix project. I really liked that back then when they had kind of like a storytelling and a more like a novel format. We don't writing a novel here, but we came up with this organization. And a couple of things I wanted to say here. Why we crafted it, because we know most organizations are not startups that start from scratch and have no legacy. Many organizations we work with have a long-term history of building software, also going through different iterations. And while this is a fictitious company, many of us, Hillary, Max, and I, we can very much relate to it. The stages that they went through, from a traditional company that built in the early 2000s 3-tier applications that was deployed by the customers, to then providing a SaaS offering where they basically hosted that software for their individual customers, increasing the release cycle, then lifting and shifting it into the cloud. And then with COVID, all of a sudden, because we are here in a fintech environment,
Yes.
new fintechs are coming up, and they're basically eating them for breakfast, or however you want to call this, but outperforming them because they have all the legacy. And so this is kind of like where we are stepping in to try to figure out how can this company improve their efficiency, their output, on both the existing stack, but also move further along and providing new capabilities. And this is very important because as I said earlier, most companies have a history, have legacy, have existing systems. And B, what's also very important, platform engineering. While the book in the later chapters will focus heavily on Kubernetes, platform engineering, as we describe it, is not constrained to onboarding new microservice only, right? Platform engineering is all about finding the pain points of current software development and software operations in an organization, and then building a self-service model or providing a self-service model for engineers to become more efficient. And this is why we created this company.
Yeah, I'm going to slightly correct you, Andy. It was my idea.
Sorry.
But you wrote the fictitious company description. So that's why you remember it so well, because basically I was writing chapter 6 while chapter 1 hadn't been written yet. And so I had done this for me in my notes because I needed it to guide the development of that building for developers in their self-service, like grounding that to something real to keep my narrative like straight and consistent and my chapter like well-defined. So but what happened was, and this was like a completely brilliant moment, as I was kind of like, I brought it to a meeting with the three of us, and I was like, this is something I'm doing for me. I think I'd like, what do you think about including it in the book? I'm thinking high level, like something fintech. And Max and Andy like, sounds good. And then like, I don't know, the next day, Andy had already churned out this entire description of the fictitious company that we have here. Like one of the fastest turnarounds in the history of book writing, I swear. And it became our kind of exactly like Andy said, it's like our guiding, for like it guides the narrative, because this is something that is like not what I don't think any like one individual customer we've seen matches this completely. It's more of an amalgamation of a bunch of different things we've seen. But the idea was, even for writing the book, I needed this to kind of ground things to reality and kind of figure out what made sense, like what took the theory into like something really more like digestible. And so like Andy did an amazing job crafting this fictitious company. I think we had exactly 0 changes to his outline about it. So this for me, like I referenced it, I go back to it several times in my chapters because I just needed that grounding for myself. And I figured if I need it and I'm writing this thing, I think the readers will need it too.
I will add one more thing, and this was from a kind of like a summit that we had in I think it was last week, We had a summit from the Canoe project. That's the project that I do work on for other companies. So these big companies got together, and there's a public doc that, and if you want to know more, this Canoe interest. But out of that, this resonates because one thing that it was brought up was a lot of these companies, and who are you doing platform engineering for, and to kind of like this caters to companies, and we see from AWS our customers, like finance, FinOps, the financial industry is one of them. Life and science is another one, and ENT, which is ENT, is enterprise, which is like large companies. And those are the ones that want to talk about platform engineering because they want to solve, not because they want to talk about platform engineering to see if they can solve the problem of migrating a bunch of VMs to the cloud or move to the cloud, or they have a large organization, but most of them they already have apps. They have literally thousand apps, services already like running in production, and they want to know like we're not looking for like how do I create a new pipeline for the new app. We're not creating more apps. So we need to have these 5,000 developers. I think the companies like Cisco and Adobe, right? They have 5,000 more developers. They have all this app already in production. How does platform engineering help them, right? At the end of the day, it's not platform engineering is the solution. It's an enabler to this. So this resonates, and it's not the startup that is trying to figure out how do I create a greenfield app. Mm-hmm. Let's think about platform engineering. That's not the answer, right? They don't have a problem yet. They're creating the first app, creating the first CI/CD. Like you don't need a platform for that. It's this type of I'll call it archetype, right? Archetype type of company that will make sense. AcmeOne. So that was a good thing, because then in the books you say like you mentioned chapter 6. So this is the company that then the rest of the book will go back to, like, we are solving this problem, like, but we solve it like this. Well, that doesn't fit for the company. This company doesn't need it. This company doesn't work like that. Is that true? That was kind of the idea. As you do the other chapters, could you go back to this company?
I think we did it in very specific, so not the entire chapter, but like very specific things where, at least when I was writing, I felt that understanding what that aspect of the chapter would look like in reality, that would be where I would bring it back to our fictitious company. So definitely did it in chapter 9. I did it in chapter 7 as well for security, because that can be super different depending on the level of regulation that the organization is subject to, like whether it's a bank or a government entity or just like something e-commerce, right? They're going to have some different levels of security and compliance requirements. So for chapter 7, I definitely did it. I don't remember. I'd have to reread chapter 6 to remember how I actually used it in the chapter. I may not have used it in the final version of the chapter the way I used it for outlining my chapter.
But talking about fintech also comes up a lot of work. It's a Gov Cloud. I do Gov Cloud public sector. So public sector and fintech, right? If you are going to build something, usually when people ask, like, you mean like certain criteria, regulations, the way of doing it, people ask like, why are you doing it like that? Well, if we don't do it, we don't go to production, because these are apps are for fintech and public sector. Like, there's no other way getting around meeting the requirement. We have to meet the requirement. We're just coming up with different solutions to meet the requirement. We're not getting a way of not meeting the requirement on that aspect. So I think that makes sense. So what about this section for chapter 3? Like, don't give your users a faster horse.
Yeah, I think the whole chapter is really aligned to basic and principal product management skills or thoughts, right? Because in the end, if you're building an internal platform that should make the life of your, let's say, engineers easier, like with any product that you're building, you first need to really understand what is the real pain of your users, and how can you then solve it. And the reason why the quote is there, right? Don't give your users a faster horse. This is a quote that was attributed to Henry Ford, as it says here. And he said, if I had asked people what they wanted back then, they would have said a faster horse. And that's like, right, if I would ask developers what do they want to build and deploy faster, maybe they want to get a new laptop or they want to get a beefier Kubernetes cluster. And that is one way to solve the problem, but it might not be the best way to solve it. It's about understanding what is the real problem and then thinking without having, without maybe just thinking about what might be possible, what they know, but really thinking, how can we solve this in the best scenario, not just for one developer, but for all of our engineers?
Great. Yeah, that's doing the, I mentioned here doing the research.
Exactly. Yeah.
For that. What about this one? Like, what does this mean? Like the sunk cost fallacy, right?
Yeah. It comes back. It was funny. I was actually at a conference yesterday in Prague, at the Engineering Leaders Conference, and I gave a talk around platform engineering. And the guy before me, he just published a book on product management and not bullshit management or something like that. And he talked about the same principles, right? He talked about when you're building a product, it's very important that you first understand what are the real needs of your user and then try to figure out a way to solve it and also measure the impact. And don't just build something and hope people come. And the sunk cost fallacy is a known kind of anti-pattern when you are investing a lot in something and you should actually stop, but you don't stop because you've invested so much time and money and you keep going even though you know it's not the right thing. That's kind of the sunk cost fallacy. And the quote that you highlight here, I think the link is also somewhere in the book in the beginning of the chapter. This is from a Reddit post from years ago.
Yep.
Where somebody said, hey, we spent months building this platform, devs hate it, help me understand why. And this is exactly because they followed an approach that did not initially include the end user of that platform in their consideration of what they actually want to build. Yeah.
Yeah, and then this also comes, I don't know if it was mentioned here in the sunk cost fallacy. That we go to the methodology, but I'll say one more thing on the sunk cost fallacy is, where was it? In the sunk cost fallacy is, this also, at least, I don't know, Max can expand, but this also comes in year planning. Like a lot of companies do their year planning of like, what are we going to do in 2026, right? Today, that's what they're probably thinking about, and how much funding we're going to put in there. And for some companies, it's difficult to see like what are the things that they're going to be in 2026 and then in 3 years. So the things that they are going to fund or the things that are going to like do next year are almost a copy paste of what they did last year. So we're going to invest on improving the CI/CD pipelines. We're going to improve on X and Y, and if we're going to do something new, we need more headcounts. Well, we cannot give you more headcounts. So what's the end result? You keep doing the same thing, which is the current solution that you may not need to invest more, and you need to invest on something new that you haven't done that in the past. So I don't know if Max has comments on that, if have happened on your consultancy world.
Well, I think it's the most difficult part for most companies because they really plan like that. It's very stiff, very inflexible itself, and even it's sometimes a little bit paradox. But if they achieve a good improvement, which you want to achieve if you implement a platform like that, then they are afraid of that someone else would take their money away because they next year don't need that much money. So they start producing somewhere else costs to keep the costs high so that next year someone will tell like, hey, you can keep that. And I think that's a little bit broken in the logic of for many enterprises customers here. I think a good product management, and if you would like to have this mindset, you on the one hand side, you need to be aware of like what is your value and which value do you bring to your organization, and how high would be the costs if not, because then you can argue to others to give a frame to your department, to your team, in which you can live within, and either grow the team or buy some other tools or I don't know, be a little bit more self-sustaining without all the time having the most craziest plan. I know controllers don't like that. The finance planners don't like that. But I mean, a few things are changing on a very short term, and that's what you need to take care of.
Yeah, and that's something that I've seen that in some planning is to write down what are the things that are the line items, right, and put a value, the return of investment. And that's, I think we talked in the past, like what is the business going to get out of like platform engineering project 1, right, platform engineering project 2. Write it down and say what is the value you're going to gain. And that's why the KPIs, I think, was the first thing. I think in the chapter 1 we talk about like why KPIs are there, because you don't get the funding, you don't get to do platform engineering. That's the end result. Nobody's going to do platform engineering on the weekends. So it needs to be in the plan. And then in the plan also you need to put this is super important, like put in there what are the things you're not going to invest, right? We're going to stop doing these things because we're going to do these others that are going to give us more value. So I think that makes sense. Let's move on to the other section on like you build kind of like a framework on and this I love these tables, and then you do the points and then the returns of investment. So can somebody talk a little bit about I think this is the first table that we're going to see.
Yeah, I think this also comes to the thing that I mentioned earlier. This comes to a problem that this fictitious company has. The developers are complaining as they're moving to a SaaS-based system. It's very hard for developers to actually get access to the production logs. Now they have more and more responsibilities. They need the logs, but it's hard to get because they are stored in a specific log tool that IT operations has. The whole scenario is explained just a little bit above the table, kind of like laying the land. And then the question is, okay, if this is a problem, then if we want to solve this problem and we want to propose a new solution, we actually not only solving a problem for the development team, because we also solve a problem for the IT operations team, who currently need to deal with all these requests that are coming in from developers to get access to the right logs, and also for the DevOps team to potentially make unplanned changes to get more logs. And so the point here is try to figure out what is the problem in an organizational level, what are the pain points for each individual team, and then later in the chapter, we talk about what would be a proposed solution and what would be the time saved if we implement that solution for every individual team, because then you can actually win teams over and say, hey, right, you're currently frustrated. Here's why you're frustrated. You're spending so much time. We propose a solution and it will be a win for you, a win for you, and a win for you.
I love that you include this one, a problem statement that is a pain, right? There could be many pain points, but I think you put this one that is inefficient log analytics. Devs are more used to the tool used in pre-production. That's what they use all the time. The production tool isn't as interesting to them as it slows them down when they need to have the access to production, right? It's not what they're used to. So this is learning about your users.
Yeah.
So perfect. I think the next table was quantifying the benefits of solving the pain point, right? Because we can say we have problems and we have a table of problems. Let's solve them all if we have an infinite amount of money and time, right? Or at the same time, in parallel, right? Like we have an infinite number of people and and we can do them all at the same time. But every pain point, you say like give a scoring system, right? Quantify what would be the benefit. Quantify the benefit of solving the problem. I think later we'll see, but it costs a lot to solve that problem, right? So I think I don't remember what's this chapter. I saw the point system. Maybe it's, but this one is quantifying on the impact, right? And this is super important. Can you say a little bit about this one of the impact?
Yeah, I think just what I said earlier, right? It's just the individual pain points that were explained in more detail in the first table. Now you cannot quantify how much time do people actually waste on this per day, per month, per year, because then you can say, hey, we have a potential here with a use case that is currently not efficient. How much time do we currently lose? And not only time, this could also then be, if it takes you very long to fix a problem, this could also be your company is exposed to a risky situation, because you don't even know if you have a problem, what the problem is. You might have a security vulnerability. You have a performance issue that you cannot solve right now because it takes you so long. So this here is focusing on how much time is currently spent and wasted to get access to logs to fix a problem. And this is then the basis of the discussion. Is this a use case that we want to solve in a better way in a central self-service platform?
Interesting. Do Najat Bakour, I don't know if you want to come on speaker, but he mentioned something around the part about about funding really depends on the organization culture. Some companies encourage various departments to be efficient by incentivizing them getting things done on their budget and giving them money back, funding back if they're doing on the budget. Not only does this builds confidence, but also makes it easy to ask for more money subsequent years. That's a great point. Some companies are run like that, is give incentives on autonomy, right? Giving them the autonomy of the budget, and if they go under budget, they can do more projects. So good. Thank you for the input.
Yeah, this is like this point is specifically true for companies that are not scaling but are stable. So their teams, stay flat. Their work stream also stays, flat for the most part. But they do have constant work, and they are incentivized to get things done, cheaper and actually give the money back.
And the other aspect on the impact is 5 days, right? 5 days a month, 60 days a year, 5 days a month. So the business will ask you to do a little bit more work, or right, or quantifying that. Well, what does that mean, right? What is the impact to the business? Are we going to get more customers because of this? Are we going to get more revenue? Are we like what is the impact? Is it funding because maybe the IT ops is a third party company that we have a contract, right? Or these are my employees, or are they how much I'm paying for this, like monetary value, right, to some of these timings, or it could be just net new customers. But like Max says, like there needs to be, I think here I said, like there needs to be a product owner, a product manager involved in platform engineering, right, to answer these type of things, because you don't want an engineer or someone that is doing software development like start looking into this, like a product owner, project manager can work with the software team to articulate the impact on solving the pain points, and then in deciding which pain points do we solve first, right? Should we solve the slow process to request log access first, or should we solve the workaround on permissions, right? That also the impact helps prioritize what things do we work first. And in platform engineering, what I've seen is you tend to work first on the things that is the biggest bottleneck, or the biggest impact one, right? The ones that move the needle. And I'm going to say, not because it's obvious, but is because it's the quickest way that you can show to your stakeholders, to that VP of engineering, that this thing actually is real, right? We can actually help the business. If the first thing that you solve is the 0.5 days one, people say like, that's nice, little toy that you have in there. And then you say, but we have more things that we're going to say, but you didn't solve the first one. Like show impact at the beginning so you can get trust and buy-in, so people let you build the other ones. I don't know, Max, or here I have seen that in the field.
Yeah. I'm thinking about it like I wouldn't point it out in that way, because it's often find so much different flavor about how it really appears in the end. Like it's become very not sure how to point it out. Like enterprises and companies always point out how unique they are and how unique the systems are. But the actual thing which is really unique is the processes and the way how they have built the organization. And from that, usually form follows functions, or the other way around, the function follows the form. I don't know. But the thing is,
you have to fit in the process that they have. Every company will have a different process, right? So you need to fit it into you need to fit your strategy into how this company works.
Yeah, and I mean, we talked about it in the last chapter about challenging Conway's law. That's exactly that, right? It's like if we as a platform engineering team do not challenge the status quo, then we have to fight more with processes and other things around it. And yeah, that's why the flavor of that one can be so much different from even teams within a same company. They're living next door and have completely different
ways that they operate or they get governed.
Yeah.
So moving along, abstraction. At first, is it the first time that we see YAML in this book? Oh my God, so. we got 3 chapters in and we never see YAML. So little prototype in here. And I think these are like starting to talk about abstractions maybe, or like the interfaces. Who wants to cover this?
Yeah, this is my primarily my chapter, my story. This was basically the same use case again. Remember, the use case is developers have a hard time accessing the logs. And so we are proposing a solution, and the solution should be something that is not constrained to a certain technology stack. So that's why we have 2 examples here. One for in general for providing metadata that you can deploy in the old architecture, where you can basically specify, hey, this is the fund transfer service in the particular version. We talk a lot about team ownership. So the whole story goes that the way we can automate this so that engineers can easier get their logs is by providing who owns a particular component at deployment time, how they want to get notified, in this case by Slack, what is the channel on Slack, in this case the backend log feedback, and then what the platform engineering team proposes if you're deploying your component, whether in the old way or let's say in Kubernetes in the new SaaS offering. As long as you specify this piece of metadata, then the platform engineering team provides an automated tool that when new logs are coming in, or when some problem comes in, or somebody requests logs, they will get the right logs sent to their channel. And this is kind of this example here.
And the abstractions, it could be that you said it's not Kubernetes. Maybe there are a lot of apps that are running on VMs and they're still in the process of being migrated or shifted.
Exactly. Yeah. Exactly, and that's why the right side is obviously deployment YAML file. On the left side, the proposal is, if you can put this service metadata YAML, that has nothing to do with a Kubernetes deployment configuration, but this was just created and defined by the platform engineering team next to your deployment in your Git repository. Then that tool that the platform engineering team builds knows which team is responsible, where do they want to get their log messages sent to, what type of logs do they want to have, right? You can see on the observability section that they want to have info logs from a certain location. So I think the whole thing makes a lot of sense if you read it from top to bottom, because you're really explaining how would we solve this problem that we initially identified. Developers have a hard time getting the logs in the various different environments and various different deployments that their organization currently has.
Yeah. And then you go down into this part of like request data on demand, notify about a problem. What are these REST API SAC posts?
It's the same use case. I think the use case is, it comes back. This part of the chapter really explains how a proposed solution can look like. So they request data on demand would be, I'm an engineer, I'm part of the the team, of a certain team, and I'm responsible for the fund transfer service. So please give me my logs so I can make maybe a call to the service that the platform engineering team provides me and then get the logs. Or when there is a problem coming in, let's say the ops team has a notification system, an observability platform that detects a problem, then they can notify about that tool that there's a problem in a particular environment, and then the platform engineering team's tool will then gather all the logs and send it to the right team. Again, this is just, I think, from top to bottom, explaining what was the problem, what is the impact if we provide a different solution, and now here we're giving concrete technical implementation solutions.
Which is a API, right? In terms of like talking about platform engineering, it's a API.
It's exactly underneath. It's an API, but then as the little gray box here on the bottom says, right? The question is, API is a good start, but maybe in the end they want to have a CLI, they want to have a chatbot, they maybe want to have a web UI. It really then depends on what your end users really demand, and this comes back to product management, because in the end we're building an internal product for an internal set of users. So we need to understand how are they currently doing their day-to-day job. Do they expect a Visual Studio Code plugin? Do they expect a CLI or just an API? Do they want to have a chatbot, or they want to have a web UI where they can click around? This is then something that you need to, as a product manager for the platform, you need to figure out.
And talking about, if you build an API for your platform, you're like, I think this is the capability. The chapter is called capabilities, right? So you're building your IDP, you're building with a capability. That capability will have an API to be consumed, and it can be consumed from different clients, right? Lenses. It could be the CLI or the web UI. And since you have that single entry point, which is the API, becomes easier to track. You may like track who's using it, how often they're using it, how to authenticate, who's allowed to use it. So that's the benefits that you get by using an API that is your central point of entry point into your platform. So that's something that talks a lot when we talk about platform engineering, like building capabilities and then building how people are going to consume this capability, right?
Yep.
What this section, I talk about the artifacts. I think this is the integration aspect of it on this, of like the fictional. I think it was having integration. Let me see. I was reading this morning. The artifact lifecycle experiment, that from idea, git commit, and production. And you talk a little bit about this?
Yeah, this section I think is called whatever you build, you first need to understand the current development process, right? Because if you build something, it needs to fit into the current way how engineers are, how this company is building and deploying and testing and operating software. And so before you do anything, you first need to understand how that works. And this is why the experiment that was explained in this little scenario that I've run with different customers in my, or users in my kind of job history, I typically say, let's make a Git change, one that doesn't have an impact, maybe just turn on a feature flag that is unimpactful, and then show me the whole end-to-end life cycle from the first Git commit until production, so that you actually understand what is the process, what are the tools that are involved, who needs to approve certain things, what is manual, what is automated, and where would we now fit in our tools to improve that process, right? And so this section here talks a lot about understanding the current process, the current SDLC, so that you can then find better ways to improve it and also integrate the tools that you are going to provide as a platform team.
But this chapter also covers, and we'll talk a little bit about the measuring, right? Trying to, if you're going to improve this process, like for example, the first was like you want it to be shown that the first Git commit, and then what are all the steps that go through it, but measuring those steps, so you can have a time or event. You can say you can emit an event to a central location, and then you can gather like what things happen when, and I can measure, start building your DORA metrics, or like other type of metrics to measure what you're going to improve. If you don't measure what you're going to improve, how do you know if it got better?
Exactly, and that's a little further down in the chapter. The point that I wanted to make here with this graphic that you just had, why we often talk about the software delivery lifecycle. It's not everything we're going to improve is the actual SDLC. In this case, coming back to that same example that goes through the whole chapter, what is the process currently that is making developers frustrated? There's a problem coming in, ticket gets created, developers request the logs, IT gets the logs, the development says we need to change the log level, we need additional logs. So this is kind of the process, the current one. And then you can also, if you measure this and you know how long it takes, and we can improve this situation, then we can later say, and now we've improved this process by X, Y, Z.
Yeah, and this is like you mentioned, all the pain points, and then collecting all the use cases that you can solve. Because it could be like for this an organization, their pipelines is not a problem. They already like did that project last year. Like, okay, we're just spending more of the time, wasting time is getting logs, right? And that could be a first problem to attack.
Yeah.
And then I think this is where I think I mentioned events, but I think this is the event section, right? All the other.
Exactly. Yeah. So the idea here is that, in the end, and I think platform engineering obviously tries to improve the end-to-end software delivery lifecycle from the initial creation of an idea until you implement it, test it, deploy it, improve it, and potentially retire. We've all seen the DevOps infinity loop. And basically the point here is also, how can we make this easier measurable and traceable? The point here is that whatever tools you have in that whole end-to-end tool chain, what type of events can they emit, and how can you link them all together? So if you have a Jira ticket in the beginning for a requirement, how can you track that Jira ticket from the Jira ticket to the first repository that gets created, or to the first pull request, then the artifact that gets built, the test that gets executed, and the deployment. So this was here basically a proposal of making all of these individual tasks along the lifecycle trackable, traceable, observable.
And what type of tools are in the ecosystem too? Because this looks like, if you screen a little bit, like an app, right? Distributed tracing. You have events. Events are things that happen once in a lifetime. Like they get recorded, and they get collected, and then they get analyzed. Like what are the tools? I heard Dev Lake. I have heard about cloud events.
I think we mentioned references here to there's different there's CD events that was initiated a couple of years ago. Now the Open Telemetry community has been adopting the CI/CD semantic conventions. So the tools that are part of CI/CD will emit spans that are enriched with things like pipeline name, version of the artifact that was deployed or created or scanned or tested. So there's currently different initiatives going on to standardize this. And ultimately, I think whether these are individual, events with particular metadata, or they're open telemetry spans that will then connect to an end-to-end trace, I think this is still in the works. But this was inspired by stuff that we are doing internally in my organization. We have standardized this internally, and now we're working with the open source community to align with what they are defining.
Yeah, I think you started a SIG. Isn't a SIG in open for this event, for this initiative? There's a SIG in open telemetry for CI/CD.
Exactly. Yeah.
Events.
Yeah. This was not me. Mentioned, this was Doten and Adriel. Yeah, they too started this. Yeah.
And I think I'm going to join because that's also a space that we're looking into, where I work on. And I'm glad that you said the two words. You mentioned And for people maybe like new to this technology, right? You mentioned the word span, and you mentioned the word trace. So I wasn't off by that much of like, this is, if you squint on it, this is like a distributed tracing, right? At the end of the day, you are trying to do distributed tracing where things are happening in different places. You collect events, and then you create a complete view of what things happen, how long they took, so you can measure and track that. So that's the angle that the group is taking on like trying to operate this.
Exactly. Currently, they're focusing on CI/CD. That means, whatever comes out of a GitHub action, GitLab workflows, out of Argo. There's a couple of things. There's some OpenTelemetry collector extensions now that are converting webhooks from these tools into spans and traces. So that will basically be a part of this infinity loop. But then, the infinity loop here starts or continues in all the way into problems, into releases, into
True. Yes.
right. I mean,
Yep.
basically, it expands to the whole SDLC. But yeah, the ultimate goal is that we want to make your complete artifact lifecycle and an
Observable,
artifact
I guess.
observable. Exactly.
Is the word, right? We always make the apps observable, but platform, it's a service, it's an app. If you do it as a product, people ask you like, how do you do observability on platform engineering on your platform, right?
Exactly. And if we have figured out a way how to trace the user interaction from the browser click to the backend database, then we can also figure out a way to trace the initial Jira ticket until it gets deployed into production.
Different systems, right? Emitting those events and then being collected. And that's why the open telemetry collector is one entry point, which I think is a good idea because it's already deployed, right? In a lot of environments. And if they're Kubernetes, probably they already is there. So it's just more extensions, right? And coming from the same project, is CNCF. So it makes a lot of sense. And then this flows into, so we have the events, they're emitting what next? Like, so what? You talk about people ask you like, well, then DORA metrics, and I think you mentioned SDLC, right? And DORA metrics.
Yeah, I mean, I think we discussed this already a little bit, but once you make things observable, once you know how long it takes to get an artifact through its life cycle, and if we can improve these things, then you can provide your proposal of the actual solution and the value proposition, and also what KPIs you can improve and how this positively impacts teams, right? For instance, if we can improve that process of your SDLC by making it easier for developers to get the log files, then we can maybe improve time to restore service by 50%. That is a great metric to then propose to your business, because that means you're 50% less down or impacted, which means you are 50% more likely to meet your SLAs and not violate them, right? So there's like, I think this is what we said earlier, you need to then sell it to the business somehow, and these are then some of the KPIs that you would sell to the business.
Yeah, and I think it's great that you took an example that is collecting logs, because it's directly correlated to the MTTR, right? To recover a service is one of the things that is taking time to recover the service. Is developers need access to the logs, then you need to measure how long that thing is taking before you start improving it. But it has an impact of the mean time to recovery, right? That which is one of the DORA metrics. There's DORA metrics to other metrics, but at least DORA or not, that's a metric you should have. Like, how long does it take to fix our problem? When we have customers calling that the website is down or it's not performing, or like, how long does it take to recover that? So you have to have SLOs. Hilary says that we'll be talking about what the term SLOs, I guess SLIs are about. I think what was the next section? I think that was this last section or not? No.
Yeah, that's
right.
I think overall, I think we are, and also seeing that we are getting at the end of the hour. There's a couple of additional considerations, right? And do we need to go multi-tenancy? I think Hilary, this was one point that you always brought up, multi-tenancy and ownership. So we also tried to factor this into this chapter, but then also referencing especially to the chapters that then Hillary wrote to go where she got deeper.
So you can say something about this, like this strike me something. IDP should be multi-tenant, not multi-user. What does that mean?
So this is about ensuring you have the right access in the right places and a proper data isolation. How many companies have you worked at where production data has been brought into test? If my answer is greater than one, right? And so that's where this comes in. So the platform needs to prevent that. And the way, like the method of prevention is through the concept of multi-tenancy. So making sure that developer teams don't have access just like blanket to something that a different team has or owns. Like that there can be centralized logging places that people have appropriate access to, where these things are sanitized. We talk about that a little bit more in chapters 6 and 7, where we talk about, the security around data and logging. But basically the idea is that it should have isolation between the personas, between the teams. Without a compelling reason, there's actually there's not good cause for developer team A to have just blanket access to everything developer team B is like running on the platform or using the platform for. And this just helps to reduce your surface area for risk in terms of like security and compliance, or just like that uncomfortable amount of room for human error that can occur when you don't really like crack down on these things.
So a tangible example, maybe there's a lot of them, but I can think on one that, and we're talking about logs. So let's talk about logs. So for example, in Kubernetes, you have namespaces, right? You have team A and team B. Team A should not see the logs of the other teams. They have pods, and for whatever is the reason, those two pods land in the same worker node. In the worker node, you usually have a single agent to collect the logs of all the containers. I stopped saying pods, by the way. All the containers on that worker nodes, and it's just grab them. It's just files, all the containers, and send them where? Let's say a central SaaS or OpenSearch or Elasticsearch, and they just whoop, they go in there. Now team A needs access to the logs. Or I need access to the OpenSearch or the SaaS provider, a Datadog, a Dynatrace, or whatever. Is that a valid use case of saying like, well, now team A has access to team B because he's just getting access to the logs? Have you seen that being done, of like people doing it and it's like, actually you have a problem because team A is going to access team B and they don't realize because they just use all the defaults of Kubernetes or like getting started?
Yeah, it's an interesting challenge, and I don't remember how much I went into logging specifically. We did go into like metrics, definitely in chapter 6. Logging is more of a challenge because when you have integrations between two different, oh man, this is such a long topic. We are already over time. We're not going to do this in 5 minutes. So the answer is, so you need to if your logs are properly sanitized and they're shipped off cluster, and then people are accessing logs through an RBAC system, there should have been already some user auditing done on that final end of things, right? Yep. So you've determined that is an appropriate level of access for them. If that's not an appropriate level of access for them, then there's the need for a service that identifies what is relevant to the teams and puts it forward. So if you look at something like Sentry used to do this, there's now an open source thing called GlitchTip that does this error and exception tracking. So if you build into an integration into your software for error and exception tracking with something like GlitchTip, which is an open source tool, which is why I mentioned it specifically, then the log error and exception tracking and forwarding will go specifically to your tenant within that system. And then regardless of what the agents are doing in terms of logging and et cetera, like you're going to see what you need for building your distributed tracing story in a way that is like secure and compliant. So that is like a very high level, like, and of course there's the if and buts, it depends pieces of this as well. So not a 1 minute topic, but that's a 1 minute summary, I guess. 2 minute summary.
Okay. Just for people to think about, right? On multi-tenancy, and like you mentioned, if you have the right RBAC systems and sanitations, and then either collected or pushed to different tenants. And then there's also the other aspects of like retention and like the other one day session on retention.
So yeah, the aspects of retention and access are a little bit covered in, definitely retention is covered in chapter 7 on security, because cool. Retention, if you retain your data for too long, that's an increase of your security, like your surface area for risk. So that's where we covered that specifically. Also, we interrogate what data we're even keeping and do we need it in that chapter.
Great. Okay. Yeah, like Andy said, we're out of time. Sorry